Okay, back again. I had big problems with these bearings in this thing, and I put some new ones in, and it's still making a little noise. Also, it used to be just running this, it would draw only 430 milliamps. Now it draws 740 milliamps from here to here. You know, measuring DC in between the inverter and the battery. And so I have this running on this inverter now. It's 110 milliamps from the AC line of the inverter. Right here. Here's the inverter AC line, about 120 volts, maybe 116 volts. It goes into this ammeter, and then this goes to number 1 line. And I have the same old transformer in series on the 9.9 ohm side, in series to the L3 line. See those 3 pieces of tape? So this goes into the transformer, just this half of it, and out that half of it. It's called a vector transformer, and it goes to the cap. The other side of the cap goes to the L2 line. You see the 2 pieces of tape. L2 line also shares a connection with one of the AC lines. Okay? So it's a 4 UF cap. Also, my last video, I put a 20 UF cap in series from here to here, right from the AC line to the ammeter, reading the current going into the motor. And I couldn't get it to happen what happened before, where it lowered the draw and it raised the amperage feeding the supercap and the battery in parallel. Again, I have the supercap in parallel with the battery right now. And a meter says there's 330 milliamps in DC feeding this, coming out of the full wave bridge rectifier on the other side, you could say the secondary side of the transformer, which is 3.5 ohms. So I've kicked it down. It's about 40 volts, 44 volts here. I put it through the full wave bridge rectifier to make sure it's DC, then I slam it into both of these at once. This is what the voltage is now across the battery and across the supercap, because they're in parallel. If I take off the supercap, and so now it's just the battery being charged, it doesn't do any difference. It's kind of weird. No difference. So it's climbing at this rate. About every 4 seconds. Goes up. 330 milliamps DC. Charging both of these. Now what I'm going to do is I'm going to take this, the battery hooked to the inverter, and run it parallel with this battery over here. So one moment. Okay, now it's loopity-looped. We have these two batteries in parallel and those two batteries in parallel with the super cap. We have these two batteries in parallel with the super cap running the inverter. The inverter AC out, about 116 volts, powers the rotoverter motor. And it's still 110 milliamps. And this is the same. And the voltage is dropping. At that rate. Now, in my previous video, when this didn't draw as much as it does now, it would drop only about 1/10 of a volt every 18 to 20 seconds. So this is really dropping. And what can I do? I'm just going to run this for a while. I'm going to clean up around here and come back to it. Maybe when it gets down around 12, below 12, it won't drop so fast. Maybe. So I'm going to put this on pause. Okay, I came back since I noticed it's not dropping so fast anymore. Maybe there's some equilibrium. That occurs. I don't know, but it's not. There it goes. Mississippi 7, Mississippi 8, Mississippi 9, Mississippi 10, Mississippi 11, Mississippi 12, Mississippi 14, Mississippi 16, Mississippi 17, Mississippi 18, Mississippi 19, Mississippi 20, Mississippi 4, okay, that's how much it drops. I don't know, it seems about 18-20 seconds it'll go down 1/10 of an amp again. Now if it would go up 0.01 volts every 20 seconds or so, that would be nice. Maybe it will, if it's way down low. Okay, I'm going to put it on pause again. Also want to say I've been thinking about this, and there's kind of some loopy logic going on. As what you would read in amperage from the battery to the inverter. Remember, this battery is in parallel with this one and the super cap. What you would read in amperage is will have, in addition to it, the amperage coming out of this transformer that's coming out of the run cap phase that's converted to DC and is charging the super cap and the battery, and the parallel two batteries and super cap. So that is this amperage, 330 milliamps. And so you would think that this amperage is part of the amperage feeding the inverter. And it's coming in on the back side of the super cap and the batteries in parallel. It's not coming in on the front side of it. It's coming in on the back side. So who knows what this means? Probably somebody does. So Hector was telling me that the battery, it's going to go down and it's going to go up and down and up and down and up and down and up in a cycle as this feeds the rotoverter. So maybe we're on the down cycle. Okay, I'm going to put it on pause again. I've been stuck at 12.69 here for a few minutes. And you know what? I gotta go. So I'm going to unplug all this. That's pretty good. I'm going to just film this until it goes to 6.68. Like I said, it's been a few minutes now. Okay, let's drop. The milliamps coming out of the inverter in AC high voltage is flashing around down to 10 from 110, so that's changing a bit. The meter turned off. Still 12.69, so this kind of likes 12.69. Same amount of juice feeding everything. Well, I'm just going to keep this mysterious and keep testing more and more. It's really stuck here. So that's good. Okay, thanks for watching.